Welcome everyone to the core of everything, where today Mark and I are discussing caves, basically how they form, which cave is the largest in the world, what's a stalactite versus a stalagmite.
Are the mines of Moria real?
Yeah, it should be a whole lot of fun.
Hey.
A bit of a delay on that one.
I feel like I just have to acknowledge them as a co-host.
Yeah, but if you just smile like you did this then,
Yeah.
no one can see that you've responded, and it's just a pit of despair.
Yeah.
A pit of despair.
I just don't know.
A pit.
Yeah. Okay.
That's
I'm sorry, Jack. I feel like I should be more appreciative of what you offer to this podcast.
Let's start off by saying, what is a cave?
Well, a cave is just a naturally occurring underground cavity. And actually, I think the definition over what defines a cave isn't particularly robust. I read somewhere online that if it's a hole underground that can roughly fit a human in, then we can probably call it a cave. I'm not sure how kind of scientific or technical that was.
Well, humans are all different shapes and sizes.
Well,
some
true,
caves
yeah.
will be massive.
Yeah.
You know.
So, but kind of on the topic of that, there's actually a really cool word that describes the exploration of caves, or like what happens if you kind of go caving. It's called spelunking. I think it's mostly used in the North American continent. In the UK, I think it's called potholing. But when I read that word, it looked like patholing.
Yeah, it sounds so posh.
Yeah.
No, but do you splunk on a regular basis?
I don't know if I ever have.
I've never spelunked.
Have you not?
Is that how you say it? Spelunked?
I think so.
Past tense? I've never heard that either, but potholing, for sure.
That just sounds like you're going around digging up holes in the road.
Yeah, it does.
Or filling them in. I don't
know. So we've only discovered 1% of all caves, and most of them don't have an entrance because they're underground, and that's because of the geology, right? We just think of the Earth as layers of rocks, or at least the crust of layers of rocks, but actually there could be huge gaps within these rocks, depending on if they've had water travel through them, or some tectonic events have actually formed holes within these rocks.
And you get this on, like, in asteroids, for example, you might find macroporosity, so like massive kind of holes where the rock hasn't really consolidated, which I guess you could probably describe as a cave.
Yeah, exactly. I mean, you can talk about cracks within the rocks as being macroporosity, that they're exploited by their planes of weakness, these little cracks within the rock, so they're exploited by tectonic forces or water, which can dissolve. So if we've established caves can be the size of a human, or if that's the definition, how large can caves actually be? And I think we found, doing a bit of research, that the largest cave is the Son Doong cave in Vietnam.
Okay, and how big's that?
We're talking, it's 9 kilometers long, so 38.5 million cubic meters, which is, if you do the maths on that, it's over 40,000 Boeing 747s can fit inside that cave. It's huge.
Wow.
It's
massive.
I would say unimaginably, but I did just say 40,000 airplanes in
That's
that
still
cave.
really hard
but it's
to imagine.
absolutely incredible. So it's big enough to fit skyscrapers.
Gosh.
So it's extremely big, and obviously there are a lot of geological processes that can form something that big. So the formation of caves is actually called speleogenesis, and it can be a combination of chemical processes, water erosion, tectonic forces. But most caves are formed by dissolution, which is basically the dissolution of limestone when water comes into contact with the rocks. And this process happens at all sorts of depths. But firstly, you need rocks that are able to dissolve, so they'd be soluble, so something like limestone. And it can't be over, I think, 3 kilometers into the ground, 3,000 meters.
Okay.
Because the pressure becomes too big and the rocks become too compact.
Right.
So you can't be forming these caves, because if you did, they would just collapse on themselves.
Right, okay. And this idea of dissolution is basically like mixing sugar into your tea, right? You get kind of interactions on the molecular level, which means your sugar can kind of mix in with your water molecules as well.
Exactly, yeah. So you've got your solute, which dissolves within your solvent.
Yeah, that's right. So in this case, the water is the solvent, and then the sugar or the rock would be your solute.
Yeah, exactly. So this dissolution process happens say up to 3,000 meters possibly, but the deepest caves that we see are in Georgia, the country rather than the state. And that happens so karst caves are seen that up to 2.2 kilometers into the earth, which is still extremely deep, but obviously not deep enough so that the pressure starts collapsing the cave in on itself. And this whole process of solution caves or karst caves is the idea that the limestone or that the rock is dissolved in acidic water. So you have like carbonates or salts or gypsum. And the acid is typically carbonic acid, which is the same acid that you see in fizzy drinks like Coke. And it's the same sort of actually acid that erodes your teeth. And so the idea that you get cavities in your teeth, it's the same process as getting cavities in the ground. It's still carbonic acid that's eroding your teeth away. And water in the caves, it reacts with CO2 to form this carbonic acid. And CO2 is sourced from the air or the decay of rotting leaves. And this carbonic acid erodes limestone, which is sort of calcium carbonate. And this leaves caves and possible sinkholes.
And actually, humans have had interactions with caves throughout kind of the whole existence of Homo sapiens. So the oldest cave that has been found is 78,000 years old, which geologically speaking is very recent, but kind of in terms of human lifespans, that's a huge amount. So that harks back to the Middle Stone Age. And this is excuse my pronunciation, the Panga Ya Saidi cave in the Kenyan Rift Valley. And actually there was a paper published in Nature Communications in 2018, and this was a kind of archaeological expedition to look at the kind of things that were in this cave. And they found that over its 78,000 year history, there'd been changes in the types of tools that had been used. So for example, I think at one point the tools became much smaller. And so they were able to kind of learn from this cave how sort of societies and communities were developing. And this cave is particularly interesting because it's in an ecotone, in a forest grassland ecotone. Now, an ecotone is just where you have a transition between different ecological communities. So they think this cave was particularly popular because it was near the forest, it was near the grassland, so you had access to good resources. And caves can be quite good as well because they protect you from processes that might be happening up on the surface.
Yeah, I think caves are traditionally, there's a lot of talk about caves in terms of migration pathways for early humans and how you can track the migration of certain types of humans that have migrated over, say, the East African Rift or across Kenya based on the tools and based on the things they were using at the time. There's sort of burial sites as well for early humans.
So we were talking about dissolving rock to form caves, but we can also form new deposits, right?
Yes, there's this common phenomenon that's called speleotherms, and these are your stalactites versus your stalagmites. So as water passes through limestone, it dissolves this calcite, so calcium carbonate, CaCO3, and when the water, as it picks up the calcium carbonate, as it gets to the cave, it reaches open air. And when it reaches this open cavern, it reacts with the air, and CO2 from the water is released, and calcite is reprecipitated on the walls of the cave. So the idea is that the water passes through limestone, it dissolves the calcite. As it hits the cave, it reprecipitates out the calcite, which forms this preservation of a droplet.
So how are we telling the difference between which one's which with the stalactites and stalagmites?
And I've heard one where stalactite is because tights roll down, because it comes from the roof and comes down, but tights can just as easily roll up.
Yeah. The way I was taught it was that stalactites are holding on tight to the roof.
Yeah, that's one, and then stalagmites
is the other one.
Yeah, might hit the roof, I think was one. And then you've got tights because there's a T in it, comes from the top, and stalagmite has a G in it, so it's from the ground.
And actually a capital T looks like a stalactite a little bit. You know, it's like connected at the roof.
Really thin, down. Narrow.
Yeah,
exactly, yeah. So the largest speleotherm, so this stalagmite or stalactite that we know, is this stalagmite, which is, remember this is just a water droplet that's been precipitated out over time. It's 70 meters long, and that's in this Songdoon cave, which is the largest cave in the world.
Wow.
70 meters is gargantuan.
And if you've been to caves or kind of seen these stalactites, you see they are typically dripping water. You almost get that like eerie underground echoey sound of like water dripping, and you see the water droplets dripping off the end of the stalactites and every time that fluid is passing over that stalactite, maybe you're precipitating like a little bit more crystal, making your stalactite, I don't know, almost like atomically bigger each time. But that, over many thousands or millions of years, it really grows.
Yeah, exactly. Yeah, I mean, it is remarkable how you can see these massive stalactites and stalagmites that are cross-cutting each other. It's almost, you go to these caves, it's like it's something from Indiana Jones, isn't it? Something precarious.
Yeah.
But a little bit more about this Songdoon cave, because it is remarkable in how big it actually is. Because it's so big and it contains skyscrapers and whatnot, it can contain skyscrapers rather than it does. A lot of species that are found in Songdoon cave are actually not found anywhere else in the world, because fish there have adapted to live in eternal darkness, which is very eerie.
Wow.
But that means they're very blind. They're very pale and very blind. And there's more than 7 new species of fish that have been found in Songdoon, and these again have transparent bodies and no eyes. And in certain areas where the sunlight can pierce through, it has primeval rainforests growing inside the cave. So it has its own sort of ecosystem, that there's a little weather and an underground river that no explorer has reached the end of. And thanks to this giant volume and the small rays of sunlight that are passing through, they're called dew lines. D-O lines. What do you reckon?
Doe lines? The lines?
The lines. Is it the lines, is it? Dew lines, that'll do. Because of how big it is, and because of these dew lines, it has its own ecosystem and a temperature stability of around 17 to 25 degrees. So something like these karst caves are sort of secondary caves, because they form, the rock's deposited, and then they form afterwards after they've been formed into rocks. But there's also something called primary caves, and these form at the same time as the rock forms.
Yeah, so an example of this would be what's known as a lava tube. So this is kind of where you have lava flowing, and it typically has a low viscosity, so it flows quite easily. And as it flows, it forms this hard crust, and that crust begins to thicken and forms a roof above the flow. And then at the end of the extrusion, so when the lava's kind of stopped flowing, you've got this crust that's formed a roof, and then you're left with an empty channel once all the lava has flown out. And these are actually really interesting features that we find in other places in our solar system. For example, on Mars, Olympus Mons, this is the biggest volcano or the biggest mountain in the whole solar system. And it's thought that these lava tubes radiate out from Olympus Mons, potentially meaning there's like a whole network of caves on Mars that we don't know about.
It'd be interesting to see, because of this debate about water on Mars, if there are any stalagmites or preserved sort of areas where there might be stalagmites or stalactites.
That would be very cool. That would be really cool. We also know that there are these lava tubes on the moon as well, and this is really helpful if we're planning to go there and take people there, because they could possibly provide habitats for missions. And there was a study done by NASA Langley and the Division for Planetary Sciences in 2001, looking at these lava tubes. So on the moon's got a lower gravity than Earth, and due to the absence of an atmosphere, basically these lava tubes can be much bigger on the moon, an order of magnitude in each direction. So like hundreds of meters wide by 100 meters deep, and like tens of kilometers long. Because we did have lava flows on the moon way back when.
I was about to ask you, the moon is a byproduct of an impact that affected the Earth, and then the debris then accumulated to form the moon. How do you have lava flows on the moon? Because there's no volcano, or is there?
Yeah, so actually we had magmatic activity on the moon for much of its history, and it's thought that it stopped occurring about 50 million years ago, but there may also be evidence of some kind of magmatic processes over that 50 million years as well. So these are like hot spots just bringing magma to the surface. The moon was presumably kind of still hot enough to have some kind of molten material.
I didn't know that. I didn't realise the moon had these sort of magmatic processes. I think most people think the moon as being this large rock that orbits us. I didn't realise it's differentiated like that.
Yeah, so like the Earth, the moon's also got layers. So we've got solid inner core, liquid outer core, and then the mantle, which, similar to the Earth, is kind of the thickest bit. It's on the moon, it's just over 1,200 kilometres. And then you've got the crust. So similar, really, in makeup to the Earth, although everything's much smaller.
Right. But the volcanic activity that occurred on the moon then to form these lava tubes, that's not going on anymore.
That has ceased, although there are some studies that think there might still be some kind of processes over the last 50 million years. Again, long timescales for humans, but geologically that is relatively recent. But the interesting thing about these lava tubes in the context of missions to the moon and beyond is that they could produce really helpful shelters from kind of natural hazards. So you've got all sorts of radiation from cosmic rays. We've got meteorite and micrometeorite impacts, or like ejecta from other impact craters. And these kind of lava tubes could provide places to build habitats, particularly because they're kind of a natural environmental control. So a bit like with the cave in Vietnam that you were talking about before, the temperatures can often, they don't fluctuate too much because they're just underground and like, you know, you don't have sunlight and things like that. So they don't undergo like extreme temperature changes like you would on the lunar surface. So lava tubes is the way forward on the moon.
If you want to live on the moon,
Yeah.
you have to be inside some magmatic chamber.
Yeah. So those are primary caves. They're forming as the rocks are depositing, but we do have some other cave types as well, right?
Yes, I mean, obviously we've spoken a little about secondary caves in terms of karst caves, where the dissolution of the limestones and salts form these caves underground. But there's also erosional caves, which essentially we described these earlier on as following planes of weakness within the rock, like faults and fractures. Basically, a fracture being a crack within the rock, and then a fault being when you have a crack and then you've got displacement either side of it. So one side of that fracture will move opposingly to the other side, and you have this. You can just identify this displacement within the rock, and so along these planes of weaknesses, you have water, and that might come in, and it can either freeze, expand, and then crack the rock up, or it can dissolve it again. But again, it's one of those processes that occurs over a long period of time. We also have sea caves, which of course you see a lot of the times along the coast, where waves come crashing against the side of the cliffs. And then the last other example I can think of is a glacial cave, or glacial cave, however you want to pronounce it. And the idea is that melting, basically with these glaciers, we have the melting ice that cause these caves within the glacier, and then the melted water sinks to the bottom and flows underneath it. So these are just large caves within a glacier as well.
That's really cool. I really like that one.
Yeah, I don't know if you've ever been inside a glacier, but you can go into these caves and you can just hear the ice moving around you. You can hear it creaking. It's sort of terrifying. So yeah, those are our types of caves. So these obviously all these different areas like along the coast or whatnot, we can go and see them, and they're quite easy to have a look at. But caves as an environment can be quite isolated.
Yeah. There's actually a real story of like resilience and survival that comes from a cave called Devil's Hole, which is in Death Valley in Nevada. So Death Valley is, I think, just called it that because it gets so hot there. Like, it's a very inhospitable place, and Devil's Hole is basically this like fishbowl of inhospitableness and warmth in Death Valley. It's over 120 meters deep. The average temperature in the cave, so it's got water in it, is about 34 degrees. So it's pretty toasty, and it's got very low oxygen levels just because it's like this isolated cave that doesn't have any like movement of water going through it to kind of oxygenate it. And for 4 months in the winter, the cave is in shadow, so that means plants aren't able to grow there. But within this cave, there is a species of fish called the pupfish, which is quite a cute name, I think, particularly given the horrors of the environment they live in. So these are like iridescent, kind of shiny blue-green fish. They don't have any natural predators, and the only place on Earth that you can find these pupfish are in Devil's Hole. So somehow they just got stuck in this cave in the past.
That's really incredible. I guess would something just fall into the cave and then evolve over time?
Yeah, you wonder whether like a bird drops it as it was
that's
flying.
a good point. Yeah,
but
possibly.
Then how do you get rid of the pupfish everywhere else? So in 2013, actually, there were only 35 pupfish in the whole entire world, and they were all in Devil's Hole. And actually, the pupfish was one of the first species to be named as an endangered species. As of this year, 2023, there are 175 pupfish.
All within the
cave
in Death
in Devil's
Valley.
Hole. Yeah, in Death Valley.
Wow.
And actually, because of this issue with the plants in the winter, if you count them in spring, there's a lot less because there's not enough plants for them to eat, so a lot of them die off.
So there are plants there then?
So there are some, it's kind of like algae and like little things like that.
Okay.
It's not a kind of a blossoming environment, but it's thought that these pupfish have been there for like up to 10,000 years, and they've survived. Like they've got cameras, like it's a kind of fully protected environment now, and they've got kind of all sorts of stuff monitoring it. And these fish have survived like flash floods. They were worried that that was just going to like disrupt the chemistry of the water, but actually it seems to have really helped them, kind of bringing in some
nutrients and stuff.
Yeah.
Right.
And
That's
there's also
remarkable.
been like earthquakes and tsunamis in the cave, in the water. And you see apparently like they filmed this event happen and all the fish were like swimming really quickly to like pass the camera to a particular place as if they knew what was happening and knew where the safe place was to go.
Are they blind?
I don't know. I think there is a little bit of light in this cave.
Right. Okay.
They quite like swimming at the surface, and apparently for the like conservationist divers who go in and feed them like supplements to maintain the population, apparently they swim up to the divers because they don't have any predators, so they just have no fear.
That's a really interesting point to end our episode on. And also, yeah, a nice little point of resilience and, I was going to say courage, but not really courage. Just, let's say
Be
resilience.
inspired by the pupfish this
The
week.
pupfish, yeah. Well, go check them out. I want to see what they look like, if they've got any eyes or not. Mark, thanks for joining again. Really appreciate it.
Thanks, Jack.
Thanks for digging deep with me into the caves. Thanks very much for listening, and see you again soon.
Bye.
Bye-bye.